the undoing of one gives you the other. First of all, you got to remember your geometry back from pre-algebra, algebra 1, algebra 2. Okay? Those things that you remember, like the area under a curve, the area under in a square, the area under a triangle, the area under, you took length times width, 1/2 base times height. So let me just give you let me just go here right quick. And I ran out of black pens and I hadn't bought any, so I've got to order some. I get them cheaper through Amazon. Just like when you were given a square back in the day in pre-algebra, and this was 4 and this was 4, the area of that is 4 times 4, or 4 squared, which is 16 square units. Okay? And then you learned that a rectangle was 2 times 6. So that would be the area of a rectangle is equal to length times width, which is the same for any quadrilateral, which is length is 6 times width is 2, which is 12 square units. And then you learned that a triangle was 1/2 base times the height.
Priority 1 message coming in.
So the area is equal to base times height divided by 2, or length times width divided by 2, or 1/2 base times the height. So area is equal to, in this case, 2 and 4. So that would be 2 times 4 over 2, which is equal to 4 square units. All right, y'all remember doing all that back in the day? Everybody should. Y'all have had algebra. Now, this is algebra, and it's set in one frame of time. The difference in here and in calculus, you're going to do like that, then like that, then like that. Oops, I skipped one, sorry. B sub D. And you notice that you remember the width of your hair? Remember in the derivatives, the width of your hair is, converging to the width of your hair from the distance, and therefore bringing that secant line down to a tangent line. Do you remember that? Well, this time your hair, the width of your hair, is going to fill in the area closer and closer and closer. Like that. And like that. Now, of course, you'd go backwards if you wanted to, and you could do it that way. But none of us read from right to left, so I don't show it that way. Okay? And it goes like that. So everybody's seeing what we're doing here? The antiderivative is what you find the area under a curve. Everybody with me? That's what we're doing. Now you could actually take another let's go with area between two curves. And you can see it here also. Now that right there you could not do in algebra because it's a curve. And this is where the calculus really pays off, because there's all kinds of applications with this within mechanical engineering, within civil engineering, within land surveying. There's just all kinds of applications in the area under a curve. And in marketing also. Marketing, you find the area under a curve. In business and economics, you find the area under the curve. And that's what the antiderivative is. And we can do a couple of different ones, and I'm not going to bore you with let me find one here. Well, I think the best one was the first one. Well, that's not what I wanted. There we go. That's the best one right there because it shows you what you're actually doing. Now, the antiderivative is the area under a curve. Now, I'm not going to go through, but I'm going to give you a short rendition of how it is, okay? The antiderivative, or the integral antiderivative, is the area under a curve, where your derivative was your equation of the slope of the tangent line. Y'all sure are quiet. Y'all just taking all the knowledge in, right?
For sure.
Yeah. Okay, so the antiderivative is the area under a curve. The derivative is the equation of the slope of the tangent line. Okay, so if I've got a curve, let's say I got a curve that looks like this, and this is 0 and this is 10. I could fill up this this area right here with boxes. What is that clicking noise? Driving me crazy. Now, I could say that this is, 1, 2, 3, 4, 5, 6, 7, 8. Darn, I'm missing 1. Oh, well. Let's just assume that these are 1. So I can take the height, which is f of x, and I can multiply the height, f of x, and get the area within all of these boxes. F of x times what? Times what? Let's say this is x times x. Okay? This would be f of x times x of 2. This would be f of x times x of 3. This would be f of x times x of 4. But what's the problem with this? What is the problem with this setup? Somebody tell me. Nobody wants to take a guess and tell me what the problem with this is?
There's an area over the curve.
Exactly. The problem is we've got this. We've got this. This is the problem. Now you could have the area under the curve or the area over the curve. I'm not going to spend a lot of time going through that. You can read your book with that. You can have area under the curve or you can have area over the curve. And I'm not going to spend a lot of time with Riemann sum, and I'm not going to spend a lot of time with that. Okay, I want you to understand how to find the area under a curve. All right. So how do we get rid of these big triangles? Now they're minimal right here, But up here, how do we get rid of them? Well, we start to use our limit theory. And we start to converge these boxes together. And the closer they are together, let's say I divide this into half. And this in 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 half. Technically this too. And this in half. What does it do now to our triangles? Well, it makes this big triangle into a what? A smaller triangle, smaller triangle, smaller triangle, smaller triangle, smaller triangle, smaller triangle, and so on. And then we divide it in half again. And what happens if we keep making these rectangles, if we keep dividing the rectangles? What happens to the triangles up top?
They get smaller.
They get smaller and smaller. So I need everybody to think of a rectangle. This is what you want to think about. A rectangle that's the width of your hair. This is dx, and this is f of x, the height. Okay, so the dx represents the rectangle, the width of your hair. And we'll call the width of that hair dx. So somebody tell me what the area of this hair is. F of x times what? F of x times dx. And that is the basis for, and I'm going to put that in green, because that is the basis for antiderivatives. That's your base, that's your benchmark for antiderivatives. Because what you're finding is you're finding from 0 to 10, the antiderivative from 0 to 10 of f of x times d of x. And you're finding the width of that hair. Now, how many hairs is between 0 and 10? Oh, it could be millions. That's where the antiderivative comes in. Okay? So, the purpose for the antiderivative is to find the area under what? It's supposed to be the E there.
Under the curve.
Under the curve. Area under the curve using the algebra that you learned back in pre-algebra. And there we go. Mixing it with the limit theory of a hairline being dx wide and being f of x high, and take the limit theory, put it with what you learned in algebra, and you have the antiderivative. Now that's kind of short and sweet, but that's what we're doing. Okay? So how do we find the antiderivative? Well, the antiderivative is that weird looking squiggle right there. That's called the antiderivative symbol. It's also called the integral symbol. There's two types of antiderivatives. There's two types. There is the indefinite. And then there is the definite. Okay, the definite does not have an a and b. It's just f of x dx. The definite integral has an a and b, like we did. Well, where is it? Here's our a, and here's our b. So that'd be 0 to 10. This right here is a definite integral. Definite integral. Okay, so there's two types. Indefinite integral is basically theory. Theory and, what is the antiderivative of 2x? What is the antiderivative of 3x? What is the antiderivative of x squared plus 2x plus 3? Okay, that's antiderivative of 2x. Antiderivative of x squared minus 2 dx. The antiderivative of x squared plus 3x minus 2 dx. Those are all indefinite integrals. Definite integrals would be, I want to find the area under a curve from 0 to 5 of x squared dx. I want to find the area under the curve from -1 to +1 of 3x squared dx. I'm just making these up. I want to find the antiderivative from 0 to 100 of x squared or x dx. Those are definite integrals. Okay. So, with that being said, we're going to work on both of these. Probably work on a lot of these today. Probably work on some of these Thursday. And I'm going to get as many as I can in so you'll know at least the basics of antiderivatives. So let's take a function like f of x is equal to, or find the antiderivative of x squared dx. And here is the basic power rule for the antiderivative. All right. It is the opposite of the derivative. Here it is. I'm going to take x, and I'm going to take 2 plus 1 and divide by 2 plus 1, and I'm going to add a c, and I'll explain that in just a second. And that's going to give me x cubed over 3 plus c. And that is a basic indefinite integral or antiderivative of x squared. Now, the reason I put the plus c. Somebody give me, if f of x is equal to 2x squared plus 3, what's f prime of x?
4x.
4x. All right. F of x is equal to 2x squared minus 642. What's f prime of x?
Still 4x.
Wait a minute. Are you telling me that these two are the same? They're not the same. They have different y-intercepts, but they're not the same function. So when I take the antiderivative, I have to think about this guy right here and this guy right here, don't I? Because they might be different. And I'm going the opposite way. So that means I've got to make up, in theory, for that 642 and that 3, because I don't know what those numbers are. So when I'm doing an indefinite integral, I got to compensate for those numbers that I don't know about. And that's why I put the C there. Will teachers mark them wrong if you don't put the C there? Yes or no?
I'd say yeah.
Yes. And I'm not talking about me. I'm talking about your persnickety calculus teachers. They will mark a problem wrong if you don't put that C. It's only with indefinite integrals. With definite, a little bit different. Okay? And that is the power rule for antiderivatives. And you add the C. See, if I give you another one, f of x is equal to 2x squared minus 1/2. F prime of x is still equal to what? 4x. So I've got the family of 4x covered, but I don't know what this next constant is. So that's why I have to put, in theory, I have to put a C there. Because that C represents these different numbers that could be added to that 2x squared. Okay, that is an indefinite integral. Let's do another one. Antiderivative of square root of x dx. What is one of the first rules of calculus? Pertaining to radicals. I've only said it like 5,000 times this semester. Radicals in calculus.
Don't mix.
Thank you. So what do you got to do here? Rewrite. So antiderivative of x to the 1/2 power dx. And that's going to give us x to the 1/2 plus 2/2 over 1/2 plus 2/2 plus c. X to the 3/2 over 3/2 plus c 2/3 x to the 3/2 plus c. That is the power rule again, except we had to rewrite first. Question on that one? Y'all keep typing stuff into the conversation, and I don't ever see it half the time. So, anybody got? Okay, thank you for your input, Miss Holcomb. Miss Holcomb needs a microphone bad. Somebody needs to give her a microphone for Christmas. Or a better microphone, one of the two. All right, here's another rewrite. And I'm giving you the basics before we move into terms, because I want to try to get to a definite integral today, because then I'll have to teach you substitution next. And that covers pretty much basic antiderivatives. So antiderivative of I'm thinking. You probably won't see this very much, but 1 over x to the negative third dx. You won't see this very often, but again, we're going to rewrite. That's going to give us the antiderivative of x to the fourth dx. And that's going to be x to the fifth over 5 plus c. And I kind of skipped a step there because honestly, some of you that are in your first calculus class, you should be able to go from here to here by the third or fourth problem. But I will add that in there just in case. X to the 4 plus 1 over 4 plus 1 plus c. Question on that one? Now, of course, you can do all your term, just single term, the antiderivative of x squared plus 2x minus 3 dx. You can break that up, or you can leave it as it is. I don't care how you want to do it, but that would be x squared dx plus the antiderivative of 2x dx plus minus the antiderivative of 3 dx. There's one more thing. You can pull out constants better, easier with antiderivatives. The antiderivative of x squared dx plus 2 times the antiderivative of x dx minus 3 times the antiderivative of dx. And just for giggles, I'm going to add, and excuse me, fluorescent blue. Since I don't have anything here, I'm going to put an x to the 0 power. Because there's nothing there, it just says dx. Okay, so this is going to be x to the 2 plus 1 over 2 plus 1 plus 2 times x to the 1 plus 1 over 1 plus 1 negative 3 x to the 0 plus 1 over 0 plus 1. It's supposed to be parentheses, sorry. And all that plus c. And you can forget about the c and add it on the end. But what happens if you what happens if you do that? What happens if you just, I'll just add it at the end? What happens on a test when you're timed?
You forget.
Exactly. And the teacher, like I said, most of the homework questions and test questions have the C on the answer, so you don't have to worry about it. But you have these sticklers that teach calculus at Tri-County Tech that make you take a in-class test when you do in the 230 class, and they make you put the C. So x to the third over 3 plus the 2's cancel because you got a 2 on the bottom. So this is 2. So that cancels with that. You're left with x squared minus, well, this is x to the 1 over 1, which is x. That's your answer. So you can take something that's got 3 or 4 terms, and you can break it up and pull the 2's out and the 3's. You can do that. Talk to me. Make sense?
Yes, sir, I got it at least.
Cool. Thank you. Thank you, Miss Holcomb and Miss Hollister. Thank you. Appreciate the interaction of 2 people out of how many? Out of, oh, great, 21. That's even better, yeah. Go Tide Pods. Any questions?
No, sir.
Thank you. All right, so let's move on. What about a definite interval? Well, I'm going to draw a picture here because I want to show you what we're actually doing. So I want you to take the f of x is equal to x squared. And we're going to draw that on a big graph. I want to just show the top because we don't need to show the bottom because it doesn't go below the x-axis. So 0, 0, 1, 1, 2, 4, 3, 9, a little bit. And there is our parabola. Okay. And I want to know the area under the curve from 0 to 3. I'm going to use my orange highlighter, even though I hate orange with dark colors like black and brown. Ugh. Can't stand orange, but I really don't like orange at all. Okay. So I want to find the area under the curve from 0 to 3. Now let's make this a little bit more real. Let's say that this is, let's say this is on the bottom. Let's say it's feet. So 0 feet to 3 feet. I want to find the area under that curve. Now we're talking about 9 feet up here. So I don't know, you're talking about like, you know, I don't know how wide, excuse me, I don't know how wide the key is on a basketball court, you know, the top of the key. I don't know how wide that key is. maybe 6 foot, and it may be 9 foot long, but that's how big of an area we're talking about. All right. So you're going to get some square footage in here, but you don't know because it looks like a triangle. You could say, but you don't know, this is 9. So 9 times 3, let's use our algebra. Algebra, can't even spell it. 9 times 3 is 27. Divide that by 2 is going to be what? 13 square feet? 13.5 square feet. Somebody check me on that. Got something in my eye. Somebody check that for me. It should be 13.5 square feet. Is it right? Appreciate it. Thanks for the interaction, y'all. Go Tide Pods. Oh, somebody did say something. Probably Miss Holcomb. Miss Holcomb, you're gonna have a nice office one day, Miss Holcomb. You're not gonna have a janitorial office with a piece of plywood over the mop sink. You're gonna have a nice office. Because you communicate. You and Miss Hollister and 1 or 2 other people in here. Rest of y'all really suck at communication. All right, so let's keep going. We're going to take the antiderivative of x squared dx from 0 to 3. And I'm speaking to those that haven't left the computer or gone back to sleep. The ones that after everybody's left, y'all are still in the room. Every class, I have like 3 people that think I'm that stupid. But anyway, so x to the 3rd over 3 evaluated at 0 and 3. Now, what did I just do? Well, I just took the derivative, and instead of adding the c, because I got a definite integral here, and since I've got a definite integral, I don't worry about the c. I put evaluated. That's what that line means. Evaluated at 0 and 3. So what does that mean? That means I'm going to plug in 3. Put a set of parentheses here, and I'm going to subtract a set of parentheses here. Now that subtraction symbol right here comes from this. That evaluation means subtraction. I'm going to take the number, plug it in 3, and I'm going to subtract the number, plug it in 0. And that, what's left, will be my area. Everybody with me? And just in case I forgot to do this, let me take a line and my ruler. Now I want somebody to tell me is our algebra estimation going to be low or high to the actual area?
Below.
It's going to be below. So this is a below estimate. If I was going to say anything, I'd say, you want to say at least 14 square feet or 15 square feet, because this one is low because, no, wait a minute, no, I'm sorry. The area we got is above. The area we got is this area. But I know why both of me and you said below. We were thinking visually, okay? The area that we have is this area right here. This is going to be above. Yes, this is above the estimate. Okay? Our estimate is above the actual area. Our area is going to be around 12 feet, 12 square feet, somewhere around there. Okay, so make sure you realize that. All right, so here we go. Parentheses squared, or parentheses to the third power divided by 3, parentheses to the third power divided by 3. Do y'all remember me telling y'all that I still use parentheses today? Buddy, when you do the antiderivative and you do the actual evaluation, you better use parentheses. Okay, I realize that some of y'all actually invented this, but for the one or two in the room that didn't invent calculus, you better use these parentheses, because you think I'm going to give you 0 and 3 on the test? That means a yes or a no answer.
No.
What do you think I'm going to give you?
I'm not too sure.
What do y'all hate? What do y'all really suck at, Mr. Melnick? Fractions and negatives.
Oh, yeah.
Yeah.
Yes, sir.
Because y'all can't read, students can't read what? A ruler. So put a 3 here and a 3 here, a 0 here. And that gives me 3 to the third is what? 27. 27 divided by 3 is 9 minus 0, and it's 9 square feet. And you've just found the area, 9 square feet. Now, in business and economics, to find the difference between the cost and the revenue, you can actually do this by the area under the curve. And you will get into that in 230. So that's why you've got to know your antiderivatives as well as your derivatives. All right, so let's do a nerd. So far, I've given you, I just want to go through this. I've given you 1, 2, I've given you 4. These are the 4 indefinite integrals. Giving you 4. And here, we're going on our second definite integral. Now, there's something different about this integral. I want to do f of x is equal to x to the third power. And I want you, hold on a second. I'm going to draw it. And sometimes you need to draw a picture, especially if you didn't invent antiderivatives. So 0, 1 is to the third power, or 1 and 1, -1 and -1. 2 would be 8. -2, -8. Of course, y'all know what it looked like because you know your parent graphs. But I want to know the area between -2 and 2. So I'm going to draw it for you. I'm going to take my handy dandy yellow highlighter. -2. and positive 2. Can somebody tell me what you notice about these two regions?
Oh, are they going to be the same?
They are symmetrical. Does that mean something? Yes.
Yes.
It does mean something. So I want you to do your now, since there is a change in direction here, you've got to set this up as two different integrals. Now, there's 3 ways you could do this. Okay, since they are symmetrical, I could actually do from 0 to 2 and multiply it by 2. So here's one way I could do it. I could add the 2 together. Now, if you add the 2 together, it's going to be a little bit different because the negative, the areas are going to cancel because they're symmetrical and they're about the what? The origin. So they are symmetrical and they're about the origin. So in one way, if you do it, you're going to cancel them out and you're going to get 0. The other way you do it, if you multiply 2 times the area, you're going to get 2 times the area. Now, why does it make a difference? If they cancel each other out, that means that they're symmetrical around the origin. Okay? And if they cancel each other out and it's x squared, then it's symmetrical around the y-axis. The main thing is symmetrical means that the 2 areas could cancel each other out. I'm just going to do from 0 to 2 right now so you can see what actually is going on. So antiderivative, we're going to do from 0 to 2. I'm going to do this area right here because I want you to see what I'm talking about. So I'm going to do 0 to 2, and that's going to be antiderivative from 0 to 2 of x cubed dx. So that's going to be x to the 3 plus 1 over 3 plus 1 evaluated at 0 and 2. X to the 4th over 4 evaluated at 2 and 0. And I'm going to set up x to the 4th over 4, parentheses to the 4th over 4, minus parentheses 4 over 4. Now, some of you are going to start seeing that when you have 0 here, is 0 a good thing to have? Yes or no?
Yes.
Yes, because you don't have to do half the work. Because what is that 0 going to do to this term right here? What does it do to any term except adding and subtracting? What does it do to most of your multiplicative and quotient terms? What does it do? It cancels the whole term out. So when you got a 0 in there, that means you're only going to do half the work. So put a 2 right here. 2 to the 4th is what? 16? And 16 divided by 4 is what? 4. So the area right here is 4 square units. So what's the area here? 4 square units. But since you have a -2 right here, that negative, what is that negative going to do to this -4? I'm sorry. What is this -2 going to do to this 4? Come on, Mr. Palmer, you can do it.
It's going to make it negative.
Thank you. And what does the negative do to this negative, this positive?
It cancels.
It cancels. When you get 0 area, that usually means that you got something symmetrical. And I can't ever remember if there's 2 T's or 2 Y's or 2 M's. It's not 2 T's, is it? It's just 1 T. Somebody help me out. It's 1 T, isn't it? Yeah. Thanks. Appreciate it, guys. So make sure you understand that sometimes if there is symmetrical and it's about the other side of the origin or the other side of the y-axis, that the areas will do what? What will the areas do if you add them together?
Equals 0.
Symmetrical equals cancel of areas. But the question may say, what is the area of both? The area of both is 8 square units. Okay? Area of both is equal to 8 square units. So sometimes the question will be a little bit, confusing when you do the first or second one. I don't know if you'll have one in this homework, but eventually you'll come to one, and we'll talk about it between now and Thursday. You'll come to one, and it'll say 8, and you like, well, it's 0. And if you put the other in, it will take the answer. And I'll have to look at the question as far as wording goes. All right. Well, what about if it's not symmetrical? Well, if it doesn't cross the negative, the y-axis, if it does left, well, with a parabola, it doesn't work because the parabola is around the y-axis. So a parabola, you'll get a positive. It's just around the origin that it becomes negative. Okay, and usually with a odd exponent. Okay, so let's look at some of the questions in the homework so we can start looking at the homework. And I'll tell you what kind of questions they are as far as if I would put them on a test or not. So assignments, and let's go down to 4.1. God, I hope they don't ask a bunch of Philadelphia lawyer questions. I want to get to the actual. Let's see. No, this is differentiation. I don't want differentiation. I want antiderivatives. Why is 3.9 and 4.1 homework? Do y'all see that? Am I crazy? 4.1, 3.9. What the? Okay, there we go. All right. So here's a test question right here. Now, of course, I would add an x in there, x to the 0 to kind of help you out. So thank you, Miss Holcomb. I see your messages, but I don't see them till I look up and see my TV screen. I'm sorry. Okay, so 4.1, number 1, this is a test question because I guarantee you, out of the 21 people in here, I bet you 5 people missed this question. That's because they've already left the room. I mean, they left their computer and are eating breakfast or went back to bed. Okay. So antiderivative of 6 dx. All right, work on it for a second. It shouldn't take you more than 30 seconds. So I just added that x to the 0 power just to kind of help me out a little bit, especially if I've never done this before or if I really suck at it. I'm going to add that 6x to the 0. And now I'm going to do, okay, that'd be 6x to the 0 plus 1 over 0 plus 1. And that would be 6x to the 1 over 1, which is equal to 6x plus c. That should be your answer. Now, I know that's very simple for some of y'all that, you know, have had probability, antiderivatives or calculus before, but you got to realize there's some people in here that's never had calculus before. And that's why I add the x to the 0 because there's no x here. So I just add x to the 0 because x to the 0 is 1. 6 times 1. So I'm not changing the quantity of the math problem. So 6x. Let's see if I type in 6x. I bet it'll say it's not right. Yep. And like I said, there are some teachers that teach 230. Oh my God. They will go into hysterics. Plus C. And nobody's going to say anything. Okay. That one's the same one. That'd be x to the 10th over 10. So x to the 10, x, shift up, 10 divided by 10. Uh-oh. X to the 9 plus 1 over, oh, plus C, sorry. I did that on purpose. I did that on purpose, just so y'all would see. Next question. Oh, there's one. Oh, yeah. There's one right there y'all will suck at. Why will you suck at it? Because it's a fraction.
It has a
Y'all know how to do
fraction.
fraction. Yeah, y'all just skip this one. Antiderivative of x to the 3 over 7. So that's going to be x to the 3 over 7 plus 7 over 7 over 3 over 7 plus 7 over 7. And that's equal to x to the 10 sevenths over 10 sevenths. That's equal 7/10 x to the 10 sevenths. Next, now let's type it in. I'm just going to hit 3, y'all. I'm not going to take less time to 7/10 x to the 10 sevenths. Next question. Okay, we did one like this one also. Go ahead and do it. Antiderivative of each of those. Now, you don't have to separate them. You can do them in your head if you want to. But I'm going to separate them just for the ones that have never seen this before. Antiderivative of x to the second negative 5x plus 5 dx. Now the rule of sum and difference of antiderivatives as well as derivatives, I can break this up into 3 separate problems. X squared dx minus 5x dx plus 5 dx. There, I broke them up into 3 different problems. Make sure you put the dx behind each one, because I have seen teachers mark the problem wrong because you didn't put the dx with each one. So that's going to be x cubed over 3 minus 5x squared over 2 plus 5x. And that's pretty much it. Now, I don't know. I'm pretty sure that this is 9 out of 25. I'm pretty sure that this is a lot of basic type problems. I'm going to try to get to some of the definite, see if they have definites. Let's do one of these because it's a little bit more complicated than the one we just did. Antiderivative of 3x squared minus 5x plus 5. And that's going to be the antiderivative of 3x squared dx minus 5x dx plus 5x to the 0 dx. And I'm going to pull this 3 out. X squared dx. And that 5x dx plus 5x to the 0 or dx. X to the 0 dx. All I did was pull out those constants. Now take x squared, that'd be x to the 3rd over 3 minus 5x squared over 2. Did we just do this one? Seems like we just did this one. Plus 5x to the 1st over 1. Of course, y'all wouldn't have said anything. Y'all would just sit there.
No, we haven't done this one.
Okay, thank you. And 3's cancel. And that leaves x to the 3rd minus 5 halves x squared plus 5x plus c. X to the 3rd minus 5 squared x squared, 5 over 2, plus 5x plus c. All right, I showed you how to do that one. 1 over x to the 10th. That becomes the antiderivative of x to the negative 10. Excuse me. Oh. So let's do that one because it's got a negative in it, or it will have a negative in it, and that'll throw some of y'all a loop. So 1 over x to the 10 dx. I'm going to rewrite antiderivative of x to the negative 10 dx. X to the negative 10 plus 1 over negative 10 plus 1. And that's going to give you x to the negative 9 over negative 9. And bring that down. That's going to be 1 over negative 9x to the 9th plus c. Excuse me, I can't stop yawning. Negative 1 over 9x to the 9 plus c. Oh my gosh, we got an index and an exponent. So what do y'all do on this? Skip it.
I already gave up.
Yeah, there you go. Good job.
Class.
Third root of x to the second power dx. All right, I'm going to let y'all work on this one. Go ahead and do it. Of course, you're going to rewrite it. Exponent over index. Oh, excuse me. Miss Krieger, have you ever gotten a lot of flack for your last name being the mad scientist on Archer? Probably not. Bless your heart. He is hilarious. Archer is the one that he trips me out. Archer is just freaking hilarious. Oh, you never taken offense to it? Wow. That's unheard of. I'm surprised somebody hadn't sued him for having the last name Krieger. Now, the funniest one on there are, thank you. Thank you, Miss Krieger. The funniest one is Cheryl. She is hilarious. That chick is hilarious. I don't know if they just got the best person to do the voiceover or what, but hilarious.
Cheever, I feel like you would make a good voiceover.
No, oh heck no.
Yes, you would.
I don't have that. No. I could maybe dang old Duke Boomhire, dang old tell you one man, dang old CK1, dang old.
I could see you being one of those guys at the auctions.
Yeah. Lord, I've spent my lifetime at cattle auctions, so I probably could. I couldn't be the auctioneer though. I never have been able to. I can listen to them and I can bid on stuff, but I can't talk that fast. So antiderivative of x to the 2/3 dx, x to the 2/3 plus 3/3 over 2/3 plus 3/3, x to the 5/3 over 5/3, 3/5 x to the 5/3. Let's see. Now, I doubt very seriously they're ever going to ask you to turn it back into a radical, because radicals and calculus don't mix. So once you turn it into a radical, I don't think they're going to tell you to turn it back into a radical. So chances are I've got the answer. Three-fifths x to the 5/3. Yep. Maybe some of these are too easy. Maybe I need to take 4.1 off the homework. All right, I'm gonna let y'all do that one. That's 10 over x to the -1. Pull the 10 out. You got x to the -1 over. So I think you can do that. I want to move on. Try to get a definite. See where they bring in definite. Okay. The antiderivative of e to the -10x. Why are they bringing this one up now? Because the antiderivative of e to the x. Okay, hold on a minute. The antiderivative of e to the x is e to the x, but I think that one's a little bit misplaced. And you need to go ahead and look this up too. Antiderivative rules. And let's see. No, we don't want those. Maybe these. Save. No, I don't want those. Just give me a second, guys. No, those confuse the hell out of you. I guess I better use these. All right, save. Let me just do this. Snip. Give me a second. I'm doing this for y'all. Snip. And I'm just going to pull these in right here. And save as capture. And pull it in Word. Insert picture. Things I do for y'all. Download. And it's on the picture, sorry. And all. There we go. You can write those down if you want to. And we're on number 2 right now. Number 2 is what we've been working with. Now, e to the x is e to the x, but we haven't covered that one yet because you got to use substitution. So I'm going to skip that one. Or they might have already moved into substitution by the end of 4.1. So let me look at it again. Go ahead and write those down because we only got 5 minutes left. That might be a good place to stop. Give y'all a few minutes to write that down. And I'll save it and send it to you. Save as documents and antiderivative. You're welcome. So y'all let me know when it comes over. I'll tell you when I'm sending it. Let's see, documents. All right, I'm sending it. Hold on, it's got to load. All right, I just sent it. Y'all let me know if you see it.
I'm not sure how we can see it without like exiting the class.
No, it's in the chat.
Oh, okay. I thought you meant you sent it as like a separate. Oh yeah, I see it.
Okay. All right, everybody's got it now, so I'm gonna move on, and I'm gonna look at. I'm gonna wait. Let me look and get out of this and go back to the question, because let me see if the next one is substitution. Yeah, when the e to the negative 9x. Okay, there we go. All right, that's going to be antiderivative would be 3x plus 2 to the third over 3. And then in the middle, yeah, that's substitution. So they've already gone to substitution in the middle of 4.1. So I need to wait. Okay, so I want y'all to work on homework through number 19. All right, everybody with me? And I'm going to cover as much as I can. So don't do that test. Don't do the last test until I figure out, you know, I know somebody already has. I don't know why you take a test because nobody passed it. I don't know why y'all would take a test, but maybe y'all think y'all know it all. So 4.1, 19, as far as I want you to go right now. And I will tell you that when you use substitution, and I got 2 minutes left, let me start you off with this. If I have substitution, let's say the antiderivative, well, I better wait. Until we have more than 2 minutes. All right, y'all work on homework 4.1 and finish the last homework and the last test. Work on 4.1 homework up to 19, and I will see y'all Thursday, okay?
Thank you. Have a good day.
All right,
All right,
Hubert,
let's
thank
see how many
you.
people left their computer.